So, as I mentioned, last time I was speaking here, it was Android Lollipop era. Things have changed. We don't use the dessert names anymore, and we have the new logo and marketing stuff. So, to be compliant with all, let me put my Android hat on. Now we are ready. Also, all the photos had the hat on, so you're in the right room. Don't worry. Cool, let's start with what's new in Android 10 UI. I'm Murat, working in Android developer relations as a developer advocate. And today, I'm going to talk about two major topics. The first one is gestural navigation and what's new with gestural navigation. And the second one is dark theme, which is super cool. I'll also mention about foldables and settings panel. Let's dive in. First, gestural navigation and going edge to edge. So probably this is the feature which is the most visible with Android 10. And if you haven't tried it yet, gestures are already start shipping with most major devices. And if you, to wrap it up, basically if you swipe from down, bottom, you go back to home, and if you swipe from right or left edges, you go back. Also, if you just swipe from bottom and hold, you go recent. Cool. Since we are more familiar with gestures now, let's see what's the status now. First of all, the three-button navigation is not going away. It will be staying, and it works really good for a lot of people. It also works great for accessibility issues. So it's staying, and three-button navigation will be there. It can be the default or optional, but it will be available on all devices. But with Android 10, almost all devices will be shipping with gestural navigation. And again, that can be optional or can be shipped as default on many devices. So why are we doing this change? And actually, why you should care? Today, we have great devices with large screens and amazing screens, which bend, curve, does really good stuff. With going edge to edge, you can build beautiful apps. And you can easily upgrade, let the user have more screen assets. So it's basically giving your users more screen for free. And what we want to make sure is the new gestures doesn't collide with your in-app gestures. So if you're using some controls or gestures, your users don't accidentally trigger system gestures instead. So let's see how you can make your app ready for gestural navigation. To start with, we will dive into two things. We will first make your app to draw edge to edge, and then we'll check out if there are any conflicts. And if there are any conflicts, we'll see how we can solve them. First, what's edge to edge? So today, this is how an app looks like. Basically, what we do is we draw our app between the status and navigation bar. With Android 10, the navigation bar became much smaller. It's not like as large as the three-button navigation. But still, we basically want it to disappear and become transparent. So your app can draw behind the navigation bar and use the space behind it. And when the user scrolls, basically all your content will scroll behind the navigation bar. With Android 10, it's strongly recommended that you draw behind the navigation bar. And if you're targeting before queue, it's optional. Still, we suggest you to do this because users will get used to it. And if your app adapts it, you will look like you're running in the latest version, even if the user's phone is not. Next, let's take a look at the navigation bar. Just like the status bar, we want it to go away. So we again want you to paint draw your app behind the navigation bar. And again, when the user scrolls, your content will be scrolled behind the status bar. Again, with Android 10, it's highly recommended that you use this and make the status bar transparent. And again, it's optional for Q. One thing to add on this may not make sense in all apps. If you have a collapsing toolbar, it may not work really well. But if you have images, especially large images on top of the screen, it works great. And you basically give an immersive and amazing experience to your users. So how do we go edge to edge? To go edge to edge, it's not really very complicated, and we'll take it in very few simple steps. You need to do three things. First, you need to change the system bar colors so your app stays behind the system bars. And then you request your app to be laid out full screen. And the third thing is, if there are any conflicts with the system UI, such as your buttons displayed under the status bars, or some gestures accidentally trigger the system gestures, you need to solve those issues. And we'll see all. But before, with Android 10, the system will help. So basically, when you scroll, you will see the screen, the navigation bar changes color automatically. And depending on the device, this can be dynamically handled, or it's just a translucent system bar. It's mostly the same with the 3-button navigation. So make sure you test your apps on different navigation modes, both the gestural navigation and 3-button navigation. But most of the time, things will work smoothly, and except for the controls, you shouldn't have much issues. So how do we start? The first thing you need to do is, of course, make the navigation bar transparent. If you're targeting Android 10, you need to edit the version 29 themes XML and add the navigation bar color to transparent. Similarly, you can set the status bar to transparent too. If you're targeting before 29, then you need to do some manual work. Because the system cannot dynamically change the color, you need to set the navigation bar color to a specific color, and usually a transparent color. Usually for the light theme, 70% white works great, and similarly for the dark theme, you need to set to 70% black. And setting your bar to translucent white or black will do the job. Next, now we basically have transparent status and navigation bar. We need to tell the system to lay our app full edge-to-edge screen. To do that, we need to use an old API, which is available from probably the beginning. We need to set some flags to system UI visibility. The first flag we need to use is flag layout height navigation, which basically tells the system to lay your app as if the navigation bar is not exist. The second flag is system UI flag layout full screen, which tells the system to draw your app as if the status bar doesn't exist. And the third optional flag is, I actually mentioned this is a very old API, and there are like hundreds of flags you can set to this API. So the third flag basically tells the system to not override your flags and lay out for the most extreme scenario, which is like drawing behind the status and navigation bar. So when you do this, your app, this is, by the way, the Android Google I/O schedule app, or maybe the Android Developer Summit app, whichever. When you do this change, your app becomes from this to this, which was not what we wanted. Basically, what happened is your FAB button is displayed behind the navigation bar. It wouldn't be this obvious if you were using the gestural navigation, but with the 3-button navigation, you basically block the user. So the next topic, the item 3, you need to solve issues with the system UI if they are overlapping. And which brings us to a new topic, which is not the favorite topic for developers, insets. Let's talk a little about insets. First, insets are basically collection of values where the system tells you where it draws the system UI on top of your app. It can also tell you where gestures take over your gestures and trigger the system gestures instead. When I say system UI, basically the first API tells you about the system UI, and it's called system window insets. Currently, with Android 10, the system window API gives you the navigation bar and the status bar. Here you can actually see the fab is not in a great position. Typically, a fab button is 16 dips away from the bars. However, when you set your app to draw behind the navigation bar, you basically lose the margin, the padding from the bottom, which is not ideal. Again, in this case, it's not obvious, and the users will be able to click the button. But what you actually want is, you want to query for the navigation bar's height and add it as a padding to your fab button. The issue becomes more obvious with the 3-button navigation bar, because now our button is basically hidden. And probably a user can click it, but that's not what you want. So again, what we want is to add a margin of the height of the navigation bar to the button and move it up. So basically, system window insets tell you which area is reserved for the system, and you can add it as a padding for your click-based controls. The next API is system gesture insets, which with Android 10 looks something like this. So if you have any controls in these yellow areas, the gestures are basically stolen by the system. And if you have any control on the right or left edge, the user will, and especially if it's a swipe gesture like carousels or controls like those, your user will basically trigger back action and go back. And it can even go out of your app, which is not the desired effect. Similarly, the bottom part is reserved for exiting your app. So if you have, again, any swipeable controls at the bottom, your users will trigger exit and will exit your app, which is, again, not the best thing to do. The third API is mandatory system gestures, which is actually a subset of gesture insets, system gesture insets API. With Android 10, the only area which is mandatory as system gesture is the bottom part. The reason is we don't want developers to block users to exit their apps. That's a very bad practice for the users, and they will hate it. So you don't want to do this. So with Android 10, this area is not allowed to opt out from any gestures and always let the user to exit your app. So we talked enough about the system insets, and now let's see how we can use them to avoid overlaps. First, we previously solved the example of how our system bars can be shown on top of our controls. In such a case, what you need to do is add a listener to set on apply window insets listener and ask for the current system insets. And by the way, you can use this over the view or the view compat. We always prefer using it over the view compat, so the API will be consistent and stable between all versions. I mentioned there are 3 different APIs: system window insets, system gesture insets, and mandatory system gesture insets. These are the APIs you will use most often. There are actually 2 more insets API, but you will end up using those instead almost all the time. Still, if you're interested, there's a great blog post from Chris Baines, which I'll give the link later. Go read, and you will learn about all the insets APIs. And all those APIs basically return you an inset object, which is roughly a rectangle of 4 pixel values. And you just need to check which one you need to use as padding. So let's get back to some scenarios. Let's say, since we know the API, let's say we have an app like this. We have a tab in the bottom, and we go through the steps. We set our navigation bar to transparent. Then we ask the system to lay our app full screen. And what happens is this. Again, this is not what we want. We basically made the text very close to the navigation bar, and we lost all our padding. So what we need to do is add a inset listener and get the current bottom inset, because that's what the height of the navigation bar is. Then we use this as padding of our view, which is our tab. And when we set this, suddenly our tab bar moves up and becomes usable again, and has the paddings and everything as we said before. Instead of padding, you can use margin, which would give a similar but slightly different effect. This time, it will leave the area in different color as the background of your app. Now, let's move to another example, which is, I mean, probably you are all familiar with this if you are using Google Photos. This is basically a linear layout with 4 buttons. And let me change the color so we can see what's going on more obviously. As I mentioned, this is a basic linear layout with padding 32 dps, which creates the button, creates the button like this. And if we go through all the steps we did before, including adding the padding value from the navigation bar, we go to this. So this is OK in terms of usability, because basically no button is blocked. They're all above the navigation bar, and users can click your buttons. But you lost your design. Basically, the whole padding values are overridden, and all your buttons are just above the navigation bar. And this might not be what you wanted. And why this is happening is you're basically overwriting your initial padding value with the height of the navigation bar, which is not what we wanted, because we want to keep the 32 dps and add the bottom value on top of it. So to fix this, what you need to do is keep the initial padding in somewhere and add that to the bottom padding every time the listener is called. Any idea why I'm keeping this value here and not in the listener? The reason is this listener can be called anytime and many times, which means every time this is called, you will be getting the previous value, which means which was added with the padding before. So every time this is called, you will be moving your button bar slightly up. And this will go forever, because the system can call this method anytime and multiple times. So that's the reason you need to keep the button padding out of the listener function. And every time this function can create the same value, not like incrementing the padding each time it is called. With this, we fixed our button bar, and everything looks perfect. As I mentioned, if you're interested in this more, go to Android Developers blog and check Window Inset's blog post by Chris Baines, and he basically explained everything. Next, solving gesture conflicts. So you may end up with some controls in the system back gesture areas. And we have a solution for this. This is again taken from the Google Photos app, and basically we let users to resize their photos. And this is not ideal because basically the drag handles are covered with the system back. In this case, what you can do is you can override the system gestures by using a new API called System Gesture Exclusion API. What you do is you basically create some areas where your gesture always takes over the system gesture. However, there is some issues with that. If you create an area which is large enough, you basically create inconsistency with other apps and the system. You basically block your users to go back. So we strongly suggest creating those areas small enough so that the user can use the controls and handles, but not like blocking some part of the screen from going back. The API is pretty simple. You basically need to call set system gesture exclusion rects API with the size of the rectangle over your view. And this call needs to be done on layout and on draw on your custom views. And if you use the initial beta versions of Android 10, which was called Android Q, and play with those APIs, you might have realized there were no restrictions. And it didn't take long to figure out that was a very bad idea, because developers, if you don't have restrictions, can easily opt out for the whole edge from going back. And again, this is like very bad idea, because you're creating inconsistency with the system and with the other apps. So your users used to go back in other apps, but they cannot go back in your app. And this is definitely not good. So we introduced some restrictions on the API. The current restriction is 200 dips from the bottom, which actually means if you ask for more than 200 dips, the system will only honor 200 dips and will just forget about the rest. That's the reason why you shouldn't be opting out the whole area next to the image, but only the drag handles, only the controls, which needs to opt out from the back. And again, this is what happens if you ask for the purple areas. We only honor the green areas, because you're asking basically too much to opt out. And if you're asking what would happen in immersive mode, the first swipe will bring the system bars, and the second swipe will trigger the gestures. There is also a dev byte which I showed about immersive modes, which should be released very soon. So go to YouTube channel of Android developers and watch it if you're interested in that. Next, back API interaction. Similarly with the immersive mode, if you are using 200 dips, the system will use the excluded areas. Immersive mode is especially good for games and video players. And in sticky immersive mode, if you're specifically using sticky immersive mode, you can opt out the whole edge. You don't have the restriction of 200 dips. But again, we ask you to do this very carefully, because having no limits doesn't mean we want you to give all the freedom. It just means if you have the use case, like playing a game, you may want to really disable the back. But that's not always the very good use case. So make sure you have the right use case to opt out from the back. Let me go a little faster to be on time. Next, dark theme, or dark theme. Let's see if the slides were good. Cool. I had some issues with dark slides before. So with Android 10, dark theme is a system-wide setting. It doesn't apply only to the system, but all apps. So, which means your users will expect to see dark apps if they switch to dark theme. This screenshot was taken during Google I/O time in last May. And at the time, Google Drive didn't support dark theme. And this was what's happening. So on the top, you'll see the Google I/O app. And at the bottom, you'll see the Google Drive app. So when the user is using dark theme and all the views are in black, suddenly your app, if not supporting dark theme, will brighten up whole display and give a very bad user experience. So users will expect to see your app supports dark theme. And there are two ways to implement it. The first one is the easy one, and of course the second one is the recommended one. So the easy one called Force Dark. Basically with Force Dark, we ask you to set an opt-in flag, and we will figure out how to change your app from this to this. Everything is done automatically, and we pick the right colors. We inspect everything, including the images, and try to see if inverting the image makes sense or not. In order to use it, again, that's not turned on by default, so you need to opt in by setting Force Dark allowed in your styles XML. And you can also disable or enable it for some activities, but not for the others, programmatically. And with Force Dark, most of the time, you will get a very good result. But again, that's not perfect. In this slide, you are seeing a Force Dark and a custom theme for Google I/O app. And you can see there are very slight differences, but they do make sense. In the first one, the header, the top bar, and the list, it looks like a single piece. However, in the next one, which might not be super obvious with the projector, but the top bar is dark gray while the list is black. So it's more obvious for the user, their different components and different controls. And also the colors are picked more suitable for your style. So try to move to custom theme and use the Force Dark only for a quick jump into dark mode train. With the custom dark theme, you need to basically extend the day-night theme. In order to do that, if you're using oops, sorry, I missed the slide. Oh, no, yeah. And when you enable it, you basically have the night resource qualifier, and every resource will have a night version, which you can add the special settings. You can also let users to pick the theme they want. So a user might be using light theme in their phone, but for your app, the dark theme might look great, and they may want to opt into dark theme. So you can programmatically call these APIs to set your app to dark theme. And we have several different modes. The first mode sets your app to dark theme all the time. The second one is obviously opts out from dark theme, even if the system is in dark. The third one follows the system. And the fourth one is interesting because it basically switches to dark theme only the battery is low. And to move to dark theme, the first thing you need to do is, if you're using AppCompat, add the AppCompat day-night. And similarly, if you're using material components, use the material components day-night. And when you do this, that's mostly what you need to do if things are right. But you may run into some issues. In this case, we have a light app with dark text. And when you switch from light to dark, this is what happens, which is, again, not what we wanted. We actually wanted this. So what is wrong here is basically this app has the text color as hard-coded in the view. which is not the best thing to do. Always use team attributes and don't hard-code your values so that the system can figure out what to do. Again, use the team colors and always rely on the team. Let's talk about another example. So we have an app, and we are using color primary purple 500, which is perfect for according to material design guides, because material design guides tells you to use mid-range tones such as 500. And if you go dark, this color is not good because, again, with the material design guides tells you to use 200 in dark theme. Well, this is not too hard to fix. You basically need to add another color. But now, what are we going to set here? Because the primary color only gets one color. So basically, we need a alias for two colors to be able to use them. You can easily solve this by going to values colors and values night colors and add two different colors with the same color alias. But that's not perfect. You're basically adding semantic meaning to a color. And that's not what we want. You always rely on the team and add your colors to the team and let the team decide which color to use. Team is the real source of the truth, and teams decide how to do styling. Let's talk about another issue. So you might have a background which is really bright and covering really large surface. And again, if you go check the material design guidelines and fix everything like I did before, you may end up with this. And again, this is not perfect because you're still emitting too much brightness, and this is not ideal for the user. The user will be using very dark background, very dark apps, but suddenly you light up the screen. In order to fix that, actually what you want to do is something like this, a more muted dark color. And in order to fix this, what you need to do is basically change from color primary to color surface. But how are we going to do that? Again, with material components, there's a support for this. If you use color primary surface instead of color primary and color surface, the system will know when to change from one to other. So basically, almost all material components support the primary color surface. Go and use color primary surface if you have a large and bright background color in your app. Again, we have resources and the time left. I have time for foldables and share sheet. Let's see foldables first. So with foldables, what I mean is fold-in and fold-out devices, which are super new. I'm pretty sure you might be thinking, there is still a lot of time for this. But actually, when we say foldables, some use cases really apply to tablets and Chromebooks too, which is like hundreds, millions of devices. So in order to support foldables and large screen devices, you need to follow some best practices. And most likely, everything will work. When I say everything will work, it's, of course, when you handle the configuration changes and resizability issues in the right and suggested ways. So when I say configuration changes, you need to check for right layouts when the screen is unfolded or used in a large screen. And you also need to check scroll views and view pages and tab navigation to see where the user is left. So you don't want to just open the screen and change to another tab where the user is actually in another one. Same applies for partially filled forms. Again, you don't want your user to lose the form when they open and unfold the device. And that's also same for keyboard focus. Resizability is default by true. So without you opting in, we assume your app will support resizability. If you don't want your app to be resized, you need to set the flag to false, and in that case, we'll basically show your app in a black box, and we will not try to resize it. With the foldables, there are new aspect ratios, so make sure you test your app with these new aspect ratios. There is also a new property called max aspect ratio. We previously had min aspect ratio, but with Android 10, you can also tell the system, I don't want to go over this aspect ratio with max aspect ratio. There is a very interesting change. So before Android 10, there can be only one app, active and resume state, displayed on screen. However, that's not true with Android 10, which brings some problems. So with Android 10, in multi-window, there can be multiple apps in resumed mode. There is a small exception for this if your app is displayed, but another app, another activity which is transparent displayed over it, or your app is in picture-in-picture mode, then it cannot be in resumed mode. But the more than one resumed app means your app might lose some resources. And when I say resources, it's not resources, it's hardware resources. So if 3 apps in resumed state are trying to use the camera, only one app will be able to get the camera or microphone or other hardware resources. So make sure you check the availability callbacks and handle on disconnect callbacks, and make sure you have the resource you want to use. Also, try to support drag and drop with the large screen and foldable devices. Especially dragging and dropping text and images makes a lot of sense. And always test. With Android Studio 3.5, we released new foldable emulators, 7.3 and 8 inches. Go and check your configuration changes, compat mode, and multi-resume on emulators. And again, if you need more resources, we have documentation and samples for foldables. Next, settings panel. Before Android 10, if your app needed to use one resource, such as network connectivity or NFC, what we were doing was basically telling the user to go to settings, which is the worst idea, because you are basically asking the user to leave the app. And by the time they went to the settings and turned on that feature, they might have another notification telling to check their status on some app, and they basically can forget getting back to your app. So that was not a very good use case. And we heard you, and we introduced Settings Panel with Android 10. With Settings Panel, we have different options for it, but basically you can turn on a system feature without leaving your app. There are a few examples here. Action Internet connectivity gives you all Wi-Fi, mobile data, and other connectivity settings. Action Wi-Fi will only display the Wi-Fi settings, and NFC will show NFC-related settings. Action Volume will show all the stream volume settings for the system. And to use this, it's basically very simple. You need to create an intent with the setting panel you want to show the user, and call start activity for result, and the setting panel will be shown to the user, and you don't really need to wait for an answer, and you can assume the user enabled that resource or just didn't want to use it. Either way, if you want to learn more about settings panel, go check our documentation and samples. And with that, I'm right on time, I guess. And I don't know if I have any time for questions. I'll be out. You can find me. I won't always have the hat on, but you can find me and we can chat about anything. Thank you.